We are here today to talk about multi-region, and I assume that if you are here in this room, it's either because you are building or you are thinking about building and expanding your architecture across multiple regions. You might be doing it for increased availability, for increased end-user performance, or for regulatory requirements. There are a lot of things to consider when doing this. Your operations will have to upskill, your monitoring will have to change, and we are here today to give you an idea of what it's like, share some best practice. I'm Giorgio Bonfiglio, Principal TAM here at AWS, and I'm joined by Rohit Singh, Senior SA. Doing resilience, it's our daily job. We are involved in customer conversations all the time about how to enhance your capabilities, get closer to users, and overall improve availability. So we are going to cover a bunch of different use cases and share some tips from real world, let's call it. So here we go. In terms of agenda, we'll start with some introduction on what multi-region means, to put you all in a position where you are able to understand it and evaluate whether multi-region is right for you, for your architecture, and for your customers. We'll then touch base on active-passive, which is the most common nowadays scenario, and active-active, which is a good goal to have over long term. After this, we'll share some follow-up resources in case you want to go dive deeper, and we'll be available for any question on the side. So before we start talking about multi-region, let's talk about a single region. So to level set on this, AWS offers services across different geographical locations. We call the minimum unit a region. A region is a set of 3 or more availability zones in a geographical area, and it's built to be resilient. Our managed services are spread across the 3 availability zones, and everything is designed to ensure that no single point of failure can affect our offering. Inside availability zones, we have 1 or more independent data centers. This is really important when to consider which is the right architecture, as by deploying across multiple availability zones, you are effectively creating an architecture that cannot be impacted by any individual power or meteorological or similar event. When talking about multi-regions, the first thing we suggest customers do is understanding requirements. This is critical to set what the goal is and where you want to go. So the first step should be understanding the current architecture. And understanding the current architecture doesn't just mean knowing how the logical blocks are connected to each other, but also understanding how it fails, how it's designed for resilience in a single region, and how it scales. The second one is defining a goal for this journey, a goal and a success criteria. So metrics that goals that you want to achieve, metrics you want to achieve, so you can actively assess your effort against that. And once we get to this point, there is an important question to ask, and it's, based on what we have seen before, can a single region meet the requirements? Can you deploy your infrastructure in a single region and meet the availability goals that you discussed earlier? And the second point is well-architected. So you surely have heard about well-architected. We position it as a way to understand, to assess your architecture against the most important pillars. One of them is fault tolerance, and helps you understanding if you are designed to deal with the most common types of failures. And the other point is, this might seem just a technical decision. It isn't. It comes with additional costs. It comes with trade-offs, both on cost and operations, and possibly ability to evolve over the long term. So alignment between the tech teams and business is important. Remember, not only in terms of goals, so where you want to go, but also in terms of how you're going to get there and with which resources. Last thing before we dive into this, 2 terms that we are going to mention quite a bunch of times today. The recovery point and the recovery time objective. So recovery point objective defines how much data you can afford to lose or to recreate, depending on the situation. It's called RPO in short, and it defines the data loss. So it defines the amount of data that you can afford to lose before a disaster happens and impairs your ability to operate. The second term, recovery time objective, is related to the cost of downtime. So once a disaster happens, how long can you afford for your infrastructure to be unavailable before your business is seriously impacted? It's downtime, in short, or recovery time objective. So the time that will take from when the disaster happens to when your critical operations are reestablished in the secondary region. A quick look at the strategies for disaster recovery. So disaster recovery is a spectrum of solution. There isn't, as I would say, there isn't a clear definition. In reality, there is a clear definition, which is restoring your business to the status where it was before the disaster. But there are different solutions that are based on the cost, the two parameters we discussed before. So the first one, which is the most common, especially for workloads that have been around for a long time, and it's backup and restore. So the main characteristic of backup and restore is that you are not running any infra in the secondary site. So you are just backing up your data, storing it on the side so that in case of disaster, you can just go back to that backup storage, pull it up, and use it to rebuild your infrastructure. It's cheap, as in the only cost that the only cost that is active 24/7 is the storage of backups. It can be a cold storage, so be much cheaper than the actual storage of your data. But it's low. Both RPO and RTO are going to be in hours with such a solution. Recovery point objective in hours, because backing up systems is complex. You cannot do it too frequently for performance reasons, and you have to transfer data off-site, which again, depending on the setup, might take time. And RTO, obviously, because when the disaster happens, at that point, you need to trigger a sequence of operations that will help you reestablishing your operations. Pilot Lite is a solution that is in the middle, and it introduced the ability to keep data synchronized between your primary and secondary site. So you are going to run your infrastructure only in the primary site, but have all of your data stores, so for example, databases with live copies in sync on the second one. When the disaster happens, you just go and rebuild your infra. Slightly more expensive. It helps shrinking the recovery point objective quite significantly, as at that point the RPO is mostly defined by the asynchronous replication strategy that you might be using. It requires some effort for rebuilding the infra. The last active-passive solution, probably the most reactive of all, is what we call warm standby. The characteristic of warm standby is that your entire infrastructure is deployed. It just scaled down. So you have a second region that is there. It's ready to take traffic. There is little to no operator involvement. And as soon as users start hitting it, then it will scale up and hit your... This is a page. Interesting. And the last one is active-active. So in active-active, you are effectively running two regions at the same time. The main advantage of active-active is that you don't have any resource that is sitting on the side and not being used by your end users. So you have additional power, compute power, because you need to be able to deal with the failure of your primary regions, but your users are landing on the secondary one and probably enjoying better performance. Now let's go back to the initial one. So operating active-passive requires to think about some specific things, especially in the scope of failover and testing. Let's look at them. Together, we'll take a sample customer like many, a fintech bank. So the characteristic of this bank is that they are all in on AWS, potentially AWS native, And the goals, so the result of the exercise that we mentioned at the beginning, are they want to improve their operational continuity and improve their testing strategy. If you look at their RPO and RTO, they are quite a goal. So they want to shrink the RPO to 15 minutes, so lose maximum 15 minutes of data. And in case a disaster hits, they want to be back in 1 hour. The architecture, we have simplified it. It's something you are going to be familiar with. So we have an application load balancer as entry points. Then we have an auto-scaling group on EKS. And then we have storage on S3 for data and on Aurora for databases. The solution they might want to go for is warm standby, based on what we said before. So you have on this side the primary region, as we discussed it. And the first step is building a second region that looks exactly the same. The third one is thinking about data synchronization. So there are different strategies for synchronizing data. Roy is going to dive a bit deeper into them later on. But essentially, you have strategies that are synchronous, so where the writer waits for the second region commit before continuing. They cause an increase of latency, but shrink RTO to essentially 0. And then there is asynchronous, where writes to the second region are put in a queue that might be really fast, but it's not going to be a full match in terms of time. And the third step is starting to deploy code in the 2 regions. I need to fix my pager. Right? Can you make this disappear? Yep. Thank you. So deploying code in 2 regions. It's extremely important to keep the 2 regions synchronized. If they are going to serve the same type of traffic and the same type of users, then you want exactly the same software to run on them. And so, yeah, look at cross-region data replications, configuration, deployments, and code as the main checkpoints, if you want, for when rolling out this infra. To summarize, the first thing to think about is keep the 2 regions in sync, but don't deploy on them at the same time. Beware, this doesn't just mean deploying one in sequence after the others. It means also including some bake time, where after a deployment, even if all your metrics are clear and are showing that the deployment went perfect, just wait some time for your users to confirm that and for your end business metrics to confirm that everything is working as intended. Choosing the right data replication strategy is going to affect how you can serve your data consistency requirements. So if you're a bank, you might not want to have a synchronous replication under your core banking. You cannot just cannot lose transactions. But if you're a social network storing user pictures, then it might be OK to wait a few seconds until the one picture shows up in a different region, or until your profile picture is updated in the second region. And the last one, we'll discuss it in a second, but remember to not take single region dependencies for recovery. It's something that might be overseen, especially if you test in a scenario where the first region is working. You might have a failover that has an hidden dependency on the primary region, and you'll never notice that's happening until something effectively breaks. Let's dive now into testing, as testing changed a lot over time. You might have heard about chaos engineering, and we launched a service a couple of years ago called AWS Fault Injection Service, or FIS. FIS is a full framework for running tests. So it allows you to affect your AWS resources in a variety of ways. Like you can block network connectivity to a subnet, you can cause an IO shutdown on EBS, and a lot of similar failure modes. What is interesting is that it allows for safety rules to be created. So you can have a test that automatically stops, for example, if a CloudWatch metric fires, showing that the infrastructure is not reacting as it should to the event. It helps with orchestrating tests across applications. So if you have, as many of you probably have, a service that is served by an infrastructure, including multiple microservices, maybe run by different teams, this can help you running those tests with consistency. It helps overall building confidence on how your app reacts under some specific failure conditions. As you know, one thing is planning for a failure, the other thing is experimenting that failure. And you don't want the first time where your teams see that failure in production to be when it actually happens. You can simulate it earlier and make sure that teams get to a point where failure is just part of the day-to-day and they can deal with it. Do not just test for binary failures. It's really easy for an infrastructure to react when an instance shuts down or when an entire availability zone disappears and becomes unreachable. It's much harder to make an application resilience to, I don't know, an availability zone starting throwing 20% packet loss for hours in a way that your monitoring might not detect. So test for gray failures. Gray failures are top of the list for what causes issues in production. And you can also use FIS to replicate previous failure modes. So if your infrastructure is impacted in a way that you were not expecting, you just go back to it, replicate the same failure, and see if the patches that you have implemented help preventing recurrence. And remember safeguards. Safeguards are easy to configure and helps the test stopping automatically, especially if you're running it in production, if one end-user metric is affected. Once you have your infrastructure and it's all tested, then you need some control for executing the failover. We launched another service called Route 53 Application Recovery Controller. And the Application Recovery Controller provides three functionalities mainly. The first one is operating the failover. So it gives you controls for flipping traffic from one region to the other. The second one is validating readiness. So it continuously monitors your second region based on, again, metrics that you have configured to make sure that it's ready for taking traffic. In an event, something should happen to the primary one. And the third one is safety rules. Like, this is quite an important big red button. You don't want someone to push it by mistake and flip all traffic to a secondary region. And so you can build rules that allow only for failing over under some specific conditions, like I keep going back to end-user metrics, and by end-user metrics I mean the highest level metric you can imagine from your company. So if you're an e-commerce, you're just measuring how many orders are coming in. It's not a technical metric. If you see that dropping, you will not immediately know which part of the infrastructure is misbehaving, but you immediately know that your business is not performing as it should. And creating those safety rules based on those metrics is generally a good idea. To summarize, continuously test both the detection and the recovery controls. Don't execute a recovery for the first time when an event happens. You want to run it before and nearly make it part of the day-to-day of your teams. Failover checks should be part of the recovery strategy. You want to be sure you know when to trigger it. You want to be sure you know that the second region is working and it's ready to take traffic. Application Recovery Controller makes it really easy to operate all of this, so go explore it. And one tip we are going to share is automate the process. So don't require any deployment for running the failover. Don't require any change. But let humans take the final decision. Let humans just take a quick glance at metrics, make sure that everything is fine, and decide that the failing over is the best decision for your business. Now, quite a common failure mode we have here. So you might be inclined to only replicate to the secondary region critical services, right? The ones that really matter to your business. And forget about things like observability. Like, you might think that you can do without observability for a few hours in case you have to fail over. In reality, without observability, you will not be able to assess, even to assess which region is impacted, right? As it might be the stack in the primary region that is not correctly monitoring the second one, and the second one being perfectly fine, or vice versa. So remember to replicate that, and not only, have those two stacks control each other. So have each region be monitored by the other one, so that you have an external point of view on what's happening. And here is where we get to the conclusion of the active-passive part. I want to highlight this point. Monitoring health from outside is a game changer in many ways. So monitor the region from the perspective, at very minimum, of the other region, but if possible from external users, so that you know how your users are actually seeing what their experience is actually like. And do not execute failovers before you have determined where the failure is. It might be confusing, might take some time, but it's going to save you time later in failing back, and it might save you time in unnecessary failovers. So with this, I'm going to leave it to Rohit to talk to you about active-active setups.
Thank you, Giorgio. So we're going to talk about the next scenario. So again, we are looking at a hypothetical customer, but it's a very realistic use case. So imagine there's a company which is a startup, and they provide authentication as a service offering. And they've seen tremendous growth over a short period of time. And as they grow and as they onboard more bigger customers, there's a constant need of them providing high level of service. Some of the customers are asking for some high SLA on the availability of their service. And also, as they've seen their service has become global, they have seen clients being onboarded from different parts of the world, they want to improve the latency. So they are looking at a couple of things to improve on. One is improve the service that they're offering, so probably 4 nines of availability, and also have set themselves a goal of improving the overall latency from all their users and reducing it by 30%. So I'll go through a really high-level brief architecture. So the application, as I said, is authentication as a service, and one of the most common API for them is read-only kind of authentication API. So the request comes in, hits an API gateway, and then the API gateway then routes the traffic depending on the type of API request. It either sends it to a Lambda function, or it will send it to a load balancer. Behind that, they have some ECS task and also some EC2 instances. So very simplistic architecture. On the data layer, they have S3 and DynamoDB, both providing the persistence layer. So as soon as they started looking at this, improving the solution, one of the first challenges they hit was they realized that as they were starting to deploy in load environments, 20% of their infrastructure wasn't infrastructure as a code. They also found some variation between what they have in the infrastructure as a code template versus what's being deployed in the accounts. So that was the first thing they had to invest in. And so they started looking at solution. They realized that CloudFormation would give them the option. So they also decided to then split the overall application into smaller stacks. So the front end was a different CloudFormation stack, the middle and the back end. So they split up the application into different stacks. And then before being able to deploy it across regions, they decided to use CloudFormation Stack Set, which allows you to deploy a specific infrastructure as a code template across multiple regions. So as Giorgio was talking about earlier, one of the safeguarded they wanted to put in place was to ensure that a deployment in one region is finished before, and then you want to give it a bit of time before they move on to the next region, that if there's any issues uncovered, they should not have multiple regions impacted at the same time. So for that, they use some CloudFormation parameters. They use some wait conditions in their templates. So this was a big learning curve for them, that they didn't want to do anything manually, and the discovery of what's in the code versus what's deployed was a learning lesson. So they made sure from that point onwards that people don't have direct access to deploy and make changes. Now, the next challenge they had was, as they moved to a multi-region architecture, is how do they route users intelligently and reliably to a stack running in a region which offers the lowest latency, and also a situation where they may have to bring one of the regions down because there's a maintenance task or there's maybe some kind of outage. So for that, they made use of latency-based records on Route 53. Now this obviously checks when the request comes in, it checks the latency across different stacks that you've deployed across region, and then returns the IP address of the stack or the endpoint which offers the lowest latency. Now, we talked about the situation where they want to make sure that while these stacks are deployed, are they in a healthy state? So for that, they took help of Route 53 ARC with the application recovery controller. And what it does is, on top of these low latency-based record, it assigns some health checks on them to make sure that the stack where the traffic is being routed to is up and running in a functional state. And then since they're security focused, being an authentication provider, they added web application firewall in front of the API gateway, which protects them against the layer 7 attacks on SQL injection, etc., and cross-site scripting. So let's take a pause and discuss some of the best practices that we've covered in the last few slides. So when you go from a single region to multi-region, the whole point of automated pipelines, infrastructure as a code, become even more relevant. So extremely important to invest time in automating your infrastructure. Do allow some bake time. So when you're deploying across region, do allow some time between deployments to make sure that if you do uncover a challenge or an issue, then you have some time between the stack gets deployed in the other region, and that way you still have an up and functioning application. And then design your routing strategy, that how do you want to route users in case of a maintenance event or some kind of an outage event. Next, we want to talk about the data layer, right? Replication of data is hard, especially when you're talking about large geographical distances. You know, we know the speed of light is really fast, but if you put in practicality, when you put this light into fiber, it slows it down by 30%. And then on top of that, you have networking protocol with further slow down the replication of traffic. So as we increase the distance between your deployments, there'll be some latency. So you have to work with those latency. And we have this concept of cap theorem. Many of you may have heard about it from the database discussions, that you have the three things. You have consistency, availability, and the partition tolerance. Now in this case, because you're deploying across two regions, you do need partition tolerance. And as per the cap theorem, when you're deploying distributed architecture, which multi-region is, you can only get two of those things. You can't have all three of them together. So as I said, you have the partition tolerance in place, so you have to make a choice between consistency and availability. Now, if you choose consistency, that means that every transaction, every write which is happening in one region has to be acknowledged on the other region before it's committed. And this, while make things consistent, would actually slow down your application, especially in long distances. So for this, they made a choice that, okay, they want to go with availability. And what they decided to do was build this intelligent SDK where when for certain API operations, which are very critical, so you're trying to revoke someone's permission or trying to change someone's permission. So when that request comes in, that's routed to both regions and they're written. And since we're using DynamoDB as a backend, so DynamoDB has a cross-region replication lag of around 1 second. So while you're writing on the both sides, and then if for some reason, for net or interruption, the write is not committed, eventually after 1 second, within 1 second, the write will happen. So you have another way to ensure that you have eventual consistency. While we're doing consistency, it's also important to have some safeguards in place. You do need observability. And as you go into a multi-region model, you'll be able to observe your application from different viewpoints. You should not be monitoring it from the region where it's deployed in, because that may give you a different view. So make sure that you're doing observability from different places, and that's what is called a differential observability. So you're monitoring the user experience, the actual user experience, and then have mechanism in place that when you're monitoring these metrics, if the latency goes up a certain number, then you have notification going out to your operation team, and they should have mechanism on runbooks available to them, and they should have practiced this, that what's the next step they need to do to bring things back to normal. So let's take a look back at some of the best practices we covered in the last few slides. So understand your consistency and replication requirements for the application, right? Utilize asynchronous replication. So as per the CAP theorem, you have those three things and you have to make a decision. Multi-region, fault, the replication, partition tolerance is a must, so you need to make a choice between availability and consistency. And then observability has to happen from different viewpoints so that you get a true picture of how your application is actually behaving. Now, one of the other things they wanted to ensure is to have complete independence of individual deployments in each region. So the whole idea of going multi-region was to avoid failure if one region is impacted, and also reducing latency. If you have some dependencies between regions, that would obviously bring the application down when you do some kind of maintenance or you have an actual outage. So the best way, which I've seen customers have been following, is to performing proper testing, as Georgie was mentioning earlier, that create those scenarios. So what they did was they managed to route traffic. So they send all the traffic to one region, and then they started observing the stack in the other region to see if that stack is actually getting some requests. And they realized there was a legacy portion of this application which was still sending some traffic to a service in a primary region or the other region. So that's something they discovered, and they obviously fixed that. So it's extremely important is to test all of these scenarios. So next thing is on the operational side. So you build this new architecture, you know how it works, you've done proper testing, but from an operational standpoint, is the operation team ready to run this application? There's also an element of cost. So this particular customer spent a lot of time and did a really good job in estimating the cost as they go from a single region to a multi-region architecture. What they didn't account for properly was the operational cost. So as you go from a single region to multi-region deployment, your operation teams need to create new runbooks. They need to update those runbooks to be able to understand how the application is behaving across those two regions. And also in scenarios, like I said earlier, that if you have a maintenance window and you have to route traffic, what are the processes you have to follow? And again, if the application is healthy state, a specific process you're following, what if the application is the unhealthy state? What do you change? How do your runbooks need to be updated? And every time you're releasing a new update for your application, those runbooks have to be continuously updated after proper testing. So it's a lot of effort needs to be put in to ensure that everything is functioning fine. So this is something we suggest customers to think about upfront, that what your day two operations will look like. Keep that in mind when you start on these kind of projects. Now, the company successfully deployed across two regions. They've kept onboarding more customers. Obviously, latency increased as they expanded from one region to two regions. Now, the next step they wanted to do is continue to expand and expand in other geos, onboard more customers. So they had to make a decision that which next region should they go for. So for that, they started collecting metrics from the internal monitoring system. They used these differential observability as well to see what the user experience looks like. They're obviously getting some support tickets from their customers. So using all of that data, they made a decision, started to think about that out of the 32 plus regions we have, where should they go next? Couple of things to think about in that scenario is the cost of the infrastructure on AWS. That'll be different because our cost of operating a region is different from region to region. And also service availability. So often people overlook and assume that every service and every feature is available, especially if you're using a newer service. It's always good to firstly understand what service and features you're using, and then finding and making sure those features are available in the other region. There's also a concept of service quota. So when you start using your account, you have some default limits on different services, and then you can raise those limits as you start deploying more applications in that account. Now, most of these limits are not account-based, they're region-based. So when you're expanding to multiple regions, make sure in your runbooks you have mechanisms to ensure that those limits are raised across all the different regions, not just the one which is currently serving traffic. So all of these are important. So let's take a pause and discuss some of the points we discussed in the previous slide. So it's extremely important to understand what are the KPIs for your application. So we discussed those, the CAP theorem. Regional independence is one of the core concepts that you have to keep in mind when you're going multi-region, so that your application can function fine if a region is unavailable. Making sure your operation teams is aware how the application works and deployed across region, how your runbooks are constantly being updated as you keep expanding. Simple things like when the metrics are coming, the metrics show which stack the metrics have been arriving from. Some of the basics of having the right dashboards in place so the teams have a clear view of different deployments. And then when selecting a region, make sure you understand the service availability, the cost of deploying in that region, and also you have operation teams ready to support that. So with that, I'm going to hand it back to Giorgio to cover, do a recap and wrap up the session.
Thank you. So let's go through what we want to be the key takeaways that you'll bring home while you bring to the office today from this session. First, two emergent ones. Build your infrastructure so that your operators are not paged while on stage at a summit. And the second one, if you are on stage at a summit, remember to mute your phone. Back to the main track. AWS regions are resilient. AWS services have resilience built inside them, and a region allows you to reach quite significant levels of operational resilience. So make sure you need to go beyond the region to achieve your goals. Define your goals. This might seem a given, but it's not always clear what are the metrics you are chasing, which are the metrics you want to improve. So if you are a tech team, make sure that the business is giving you those metrics, that the business is telling you what they consider success for your team. And if you are the business, develop those metrics. Have KPIs really high level that can help all the teams supporting the infrastructure, knowing if they are doing a good job or not. Observability is important. Having a failover strategy without good observability will never allow you to operate such failover strategies. So make sure you know exactly what's happening in your infrastructure, that you have the capability to isolate failures and to understand what's broken and where. And continuous testing is extremely critical as well. As said earlier, don't react for the first time when an actual failure happens. Make sure your teams get familiar with failures and with recovery before you really need that. Dependencies are complex. It's it's extremely easy to have a dependency from the primary region to the secondary and never notice until that dependency breaks. So make sure that in your test scenarios you are properly isolating the networks, making the primary region unreachable so that such dependencies show up. You might get there on paper, but it's way easier to find those dependencies by testing. And testing will also help with all of the topics and familiarity that we discussed earlier. And keep failure boundaries in mind. So if you want a region to be independent, then make sure that your teams, the tooling supporting your teams, doesn't allow them to deploy in two regions at the same time. Make sure that your firewall policies, for example, don't allow the API fleet in one region to call the database of the other region, right? Preventing network connectivity, preventing incorrect network flows, it's really easy and helps you not creating dependencies where you don't really want them. So let's discuss some next steps and how you can keep diving deeper into these. First, we just mentioned 2 AWS services today, but we have been investing quite heavily in the last few years in developing purpose-built services for improving resilience of your application. So we touched base on fault injection simulators, which helps you with continuous testing of your hypothesis and the availability of your application. We mentioned Route 53 application recovery controller to help you operating the failover and ensuring readiness. We also have Resilience Hub, which continuously monitor your infrastructure and your workloads to make sure that they are ready and that they are designed for resilience as you expect them to be. Elastic Disaster Recovery helps you nearly seamlessly failing over from one deployment to the other by keeping data in sync and automatically switching in case of need. AWS Backup is an easy way to enforce backup policies across an entire organization. It helps removing the weight from teams to follow a runbook or a script that is written in a wiki page and just enforces it in policies, so you can be sure that everything is being backed up against the rules you defined. And AWS Solutions, it's our repository of nearly fully built solutions for specific use cases where you can always go look in case you want to build something and see if we already have a reference solution for it. In terms of further reading, the AWS Resilience Framework, Lifecycle Framework, we published it last year, and it helps you thinking about what we didn't discuss in this talk. So it helps you getting into the mindset of seeing resilience as a continuous journey, where you define goals, build to achieve them, and then reiterate on those goals over time. It defines 5 stages for achieving resiliency, and it might vary how you implement them in your company, but it gives an idea of a good framework to start thinking about resiliency maybe beyond the let's just back it up kind of strategy. And if you want to go deeper than we went today, the AWS Multi-Region Fundamentals white paper, it covers understanding the requirements, so it covers the starting of the multi-region project. It covers how to handle data and how to track dependencies over time, and also sets a base for operational readiness and ensuring that whatever you have built is ready to go live and support the business objectives. And last one, we talked a lot about technology today, but it's down to humans to build it, and it's humans building all of the infrastructure we talked about. So Skill Builder is our training platform. Skill Builder contains hundreds of trainings for different areas and helps you getting ready for AWS certification. So whether you have been in the industry for a while or you are just getting started with AWS, please go take a look. Skill Builder helps you either with specific training on specific services, whether you want to get started and just take a look at something new, or with training for our certifications. And certifications are widely recognized in the industry. They are a good idea, but to start, if you are a student and want to get into the AWS world, then starting with SA Associate is an amazing way to just get the level 100, level 200 knowledge that you need. And if you have been operating infrastructure for years, but not on AWS, then SA Associate and SA Pros are good ways to align your knowledge of what's traditional IT towards how you run the same things on AWS. And with this, thank you. Sorry for the page. We are going to be here in the room in case you have any question or follow-up, or feel free to take a note of our email addresses and follow up if you have questions, or if in a few months you end up coming back to this talk. So thank you, everyone.